Hello everyone and welcome to this video. So in this video, this is the second video of our Scikit-Learn series. So today we're going to be looking at a typical Scikit-Learn workflow. So I'm going to demonstrate a typical Scikit-Learn workflow so you guys are familiar with it. So you have to be familiar with this because we're going to be working with this along this workflow throughout the whole series. So that is why I am going to demonstrate it today. So yes, let's get on to that. Okay, so here I am at, so this is basically my empty Scikit-Learn folder that I created in Jupyter Notebook. So we're going to create a new Python 3 notebook. And we're going to call this, we're going to be calling this notebook Introduction to Scikit-Learn. Okay? So Introduction to Scikit-Learn, that's what we're going to call it. So we're going to write a big bold heading. And by the way, I got these line numbers. So I pressed Ctrl-Shift-L to get line numbers. So if you'd like to get the line numbers, I keep on getting caught up with my words. If you'd like to get the line numbers, then just press Ctrl-Shift-L because it works. So we're going to write in big bold writing, in big bold markdown. Okay, let's just write big Introduction to Scikit-Learn. Okay, make sure you capitalize this because that's important, sort of. So we'll just write in brackets here Scikit-Learn. Okay, so underneath that I'm going to write this notebook demonstrates. Did I spell that? No. Demonstrates some of the most useful. So because we're going to look at the useful functions. So some of the most useful functions of the Scikit-Learn library. Okay. So that's what we're actually going to be looking at in this notebook. Okay. So this is what we're going to cover. So I'm actually okay, so I'm just gonna put this nicely. There you go. So what we're going to cover. So I'm going to actually, so what I was thinking is we're going to listify the content. So let's listify the contents because as our notebook will probably get even bigger than matplotlib and numpy, as it gets really big we are going to want to refer to what we're doing in each lecture. So that's why I'm going to listify to it so we can literally index to that every lecture. Okay, so what we're covering. So basically this might be a bit different to what I explained in the previous lesson where I explained what we're going to do. So basically so it might be a bit different to last time Scikit-Learn workflow that I showed to you guys because I just made this one a bit more sort of like explanatory. So we're going to actually index with Python list. So number 0. So we're going to look at an end. Whoops, we're going to look at an end to end Scikit-Learn workflow. Okay, so that's the first one which you're going to be doing today. And then number 1 is we're going to be getting the data ready. So that's the next lecture. We're going to learn how to get the data ready, how to split it so it's ready. Okay, so don't worry about it right now. We're just going to be looking at an end-to-end Scikit-Learn workflow where I'll be demonstrating all of these steps. So then it is, after that it's number 2 or number 3 if you want to do it. So we're going to learn how to choose the right estimator, which basically means model in the Scikit-Learn usually uses estimator, but we're going to call it a model. We might call it estimator, but it doesn't matter. So we're going to choose the right estimator for our problems. Okay, so we have a problem, we're going to solve it by and we have to choose a right estimator for that. Then number 3 is to fit the estimator and use it to make predictions on our data. So that means like getting our machine learning model used to it and sort of training it a bit, so that it's all ready to go. Number 4 is evaluating the model. So we're going to be testing the model, so like giving it an final exam and sort of evaluating its results. And then if the results are not up to our standard, we're going to improve the model. Okay? And then after that, is number 6. So we're nearly gotten to the end. Is to save and load a trained model. Okay? And then, well, we're not going to be doing that in this lecture, but we're going to be like probably the last video of this series, we're going to be putting it all together. Okay, exclamation mark. So that's the contents of this whole series. So now let's get back onto what we're doing. So the first important thing we need to do is we need to import all the libraries that we need. Okay, so we're going to import all the libraries that we need. So first library is we're going to import NumPy as NP, and then we're going to import pandas as PD, and then we're going to import matplotlib.pyplot as PLT. So yes, we're going to be using a lot here. And then after that, we're going to want to do matplotlib inline, so the plots appear within our work. Okay, so we're soon going to be adding way more libraries up here as you get deeper into the series. So now let's actually start. Okay, so yeah, so the first thing I'm going to do is no mod from NumPy. Okay, so the first thing I'm going to do is I am going to add a subtitle to our thing. And why is this taking so long? Okay, so let's just wait for that. Let's just write in our subheading. So number 0 is a end-to-end Scikit. Gosh, the word Scikit is actually pretty hard to type. So an end-to-end Scikit-Learn workflow. Okay, so that's what we're going to do today. So step 1 of our Scikit-Learn workflow is to get the data ready. Okay, that's the first step. So I have this heartdisease.csv that we used in the matplotlib section, but I did alter it a bit. So I'm going to be putting that in the link description below. So you guys can go ahead and click on that and download the thing. Because I did alter it a bit so it suits our library, the learning we're going to be doing on this library. Okay, so I added a few more columns and I altered it a bit okay? But don't worry, it's not going to change too much. So we're going to do heart disease is equal to pd dot read CSV, and it's called heart disease dot CSV. So autocomplete, there we go. And then I'm going to view my heart disease. Again, it's very big. It's 303 rows times 14 columns. So this time I added this target column at the end, okay? So this is the target we're going to be getting to in our machine learning column, with our Scikit-Learn models. Now you'll see what I mean in a minute. And we've got all of this confusing stuff, but don't worry about that right now. So the first thing we want to do is when we create data, there's three things we want to do. So we want to create X, which is capital. So so the X is actually so the X is the data that so X is all of this data except target, because target is our target basically. So X is known as a features matrix. So that's the data apart from our target. And then there's also a Y, so create Y, that's lowercase now. And this is our target itself, so that's a label matrix. Okay, so a features matrix, X is features matrix, and Y is label matrix. So if you don't understand this, we're going to be looking at this in the next video, where we're going to be learning how to split this data. So we're going to create X, capitals, remember. So we want all the columns other than our target column. So what we'll have to do is, so X is equal to heart disease dot drop. Okay, so we're going to drop the column target, which is on axis 1. So basically it's on a column, row is axis 0. Okay, so we're going to drop that, which means we're going to take it out, and that will be equal to X. And then Y is the complete opposite, so Y, lowercase, is equal to heart disease, and then we'll simply just take the target column, okay? So now we are going to do the next step. So step 2 is to choose the right model and hyperparameters. Okay, so hyperparameters are basically like levers or knobs, whatever you want to call them, that will let you sort of like customize your model. Okay, just think of it like that. It's pretty simple to think about if you think about it that way. So I'm going to say from Scikit-Learn, so this is where we use Scikit-Learn reference, dot ensemble. So Scikit-Learn does have a lot of packages in it. So we're going to import random forest classifier. Okay, so basically random forest classifier is a type of model. Okay, so usually we would say model is equal to, and then random is equal to random forest classifier, but I'm going to see CLF is equal to. Okay, so CLF is equal to our random forest classifier. Okay, so that's basically CLF is equal to the actual random forest classifier. Now you might not know what CLF means, but as you're going through the video, you will start getting used to it, as you will see it quite a lot. Okay, you can search it up if you like, but I wouldn't recommend it because it's actually sort of obvious now, but I'm not going to tell you. So CLF is equal to random forest classifier brackets. Okay, So usually people would call it model, so don't be confused. So you'd usually see model, but we're going to call it CLF. So right now we're just going to keep the default parameters. So I'm going to write here, we'll keep the default hyperparameters. Okay, so don't worry about changing it, but we're actually going to look at the hyperparameters. So clf.get params, and it will take some time because there is, well, not too big, but it is quite big. Okay, so let's just check. Well, not check, but let's just look. Okay, so here we go. We've got all the default values of all of the parameters. So yeah, so you will come across one of these. Okay, so so now we're on to the third step. So number 3 is to fit the model to the training data. So first you want to split the data into a training set and a testing set, and then we're going to fit it. So let's just split the data first. So from Scikit-Learn model selection, import train test split. So that's basically going to split our data into training data and some testing data. So testing data is like the final exam, and training data is just like revision for our model. So we're going to say xtrain, so that's x with capital letter, xtrain and xtest, and then ytrain and ytest is equal to train test split. So we can't look at what it does because we haven't actually run this cell yet. So basically we need to pass in the features matrix, so that is x, and then we need to pass in the labels matrix. Okay, and then we need to pass in the test size. So this is the size of our testing data. So we want 20% of all of the whole data altogether to be our training data. So now let's run it. Import error. Train test applet. Wow. Train test split. There you go. So yeah, so that has not given us any errors. Thank goodness for that. So now we're going to fit the data. It's very easy. So clf.fit. We're going to fit the data to the xtrain. Make sure you don't put in test. Otherwise, we're going to reveal the final exam to our model. So we only want all the training data to be revealed. So xtrain, ytrain. So that's going to give that. But sometimes if you have an older version of Scikit-Learn, it might give you an error saying that the n estimators might change. So if that is the case, then what you're going to want to do is you are going to when you do that, you might want to change the change the n estimators, but I'm sure you all have a very recent model. So you want to so my n estimators are actually 100 because I've got the recent version right now. But it would say if you haven't, well, that's a bit bad. You're just going to want to do that. So if here you say random forest classifier and then you put in n estimators is equal to 100 hit, in case it says, because I think it's 22.0 is the most recent version. So make sure you've either got that or you just set n estimators, the n estimators parameter to 100 in random forest classifier. Okay, but I'm sure you all have got the most recent one. So now what we're going to do is we're still part of step 3. So we're going to now make a prediction. Still part of step 3. So I'm gonna say y, no, so not y label, what am I, why am I even, yeah, so y label is equal to clf.predict np.array, okay? And we're going to create an array here, so we're gonna say 0, 3, 4, 6. How about that? And now that is going to give us a big error. So expected 2D array got 1D array. So it is giving us that error because this array is not the size of our training array. So if we just check out x train, this is 242 rows, 13 columns, and this NumPy array is nowhere near that. But you know what is? It is Y train, or yeah, is it Y train? Yes, it happens to be Y train. Okay, so wait, not Y train actually, Y test. Okay, it happens to actually be the same sort of size, okay? Because this is one dimensional, and so is our NumPy array. So that happens to be the same size. So we're going to, let's do it after that. So we're going to create a Y preds. So that basically means Y predictions is equal to clf.predict. We're going to predict on X test, okay? And then we're going to view our Y preds. And there we go. So now that is about the that's about the same sort of thing. So now we have actually sort of prepared our model. So now let's evaluate the model on our training data, and then we're going to do it on the test data. So we're going to give it a test now. So I'm going to write number 4 is to evaluate the model on the training data and the test data. Okay? So first thing, we're going to say clf.score. We're going to score X train. So we're just gonna give it a test on the training data first. So X train and then Y train. It should be pretty good. There we go. We got 100%. So 1 basically means 100%. So then we're going to take it to testing data. So we're going to say clf.score. We're going to do a testing data. If it does come 1, then that's going to be bad, because basically it's bad. Okay, so that is a pretty good result, but it's not got 1. It's not got 100%, which is good, because if it did, then there'd be then that means you'd accidentally revealed the testing data, which you shouldn't have done. So that is a pretty good score. So to view this score another way, we can do this. So we're going to say from Scikit-Learn dot metrics, we're going to import classification report. We're also going to view confusion matrix, and we're also going to view accuracy score. So this is basically the exact same score we can see here. So the first thing we're going to do is I'm going to print my classification report. So we're going to put in Y test and then the Y predictions. So classification classification. There we go. So that's more detail. So if you want to just see why we put in ypred, so here it says y true or y test, and there it says ypreds. Let's just scroll down. So the parameters y true or y test is a one-dimensional. So that's why we got one-dimensional. One-dimensional array like or label indicator array sparse matrix. So this is basically a label label matrix. Okay, so that's good. And it's the ground truth, which is correct, target values. So don't worry about that. And then y predictions, it's again a one-dimensional array. It's a label array as well. So it's estimated targets as returned by a classifier. Okay, so this is what it has given us. So it's rounded these values to the nearest two decimal places. Okay, so we're also going to check out confusion matrix. So I'm going to say confusion matrix y test and y preds. So it's given us an array. So 18, 8, 2, 33. Okay, so let's see again what confusion matrix does. So compute confusion matrix to evaluate the accuracy of a classification. Okay, so that's what it does. And then finally accuracy score. So if you don't actually if these are actually confusing, don't worry, we'll probably go through it throughout the series and then you'll be very familiar with these. So we're going to also go accuracy score, y test, y preds, and it should give us the same accuracy score from here. So now, well, we want to improve that, don't we? So we're going to do number 5, which is improve our model. So what we're going to do to improve this model is to try a different amount of n estimators. So we do not need to do this individually for everything. What we're actually going to do is we're going to be using a for loop. Okay, so the first thing we're going to do is we're going to set a random seed. So np.random.seed, let's set 42. Okay, so I'm going to say for I in range. So if you're still confused about for loops, I have a video on that, and yeah, you can watch that too. So for I in range 10 to 100, and you want to go up in tens for that range. So we're going to have 10, 20, 30, 40, etc. Okay, so for I in range from that 10 to 100, steps 10. So what we're going to do is we're going to print. I'm going to use an F string. So we're going to print trying model with I estimators, and we're going to have to put I in curly brackets. Okay, because I is what we want to put in, so it will be trying with that I estimators. So how many, what the number is. I will be a certain number, it will try with that many estimators. Okay, so then what we're going to do is, if I just do that, there we go. So then what we're going to do, let me just put a dot here, there we go. So after that, we're going to go CLF, so we're going to reassign CLF is equal to random forest classifier. We're going to do n estimators is equal to, make sure this is inside your for loop too, is equal to I, okay? So it's going to be equal to that many, and then we're going to fit it afterwards. So we're going to fit the X train. We're going to fit X train and Y train to the data, to the model actually. And then we're going to print the accuracy score of our model on the test. So again, I'm going to do an F string. So my F string I'm going to include. So model accuracy on test set is, so in curly braces, so this is what we want to insert, is clf.score. So we're going to check the score of X test and Y test. And then let me just put the curly braces and the bracket. So we're going to do that. So clf.score, X test, Y test. Let's put that bracket there. Well, actually, we don't need that bracket. So yeah, so okay, so this is, don't worry about that. So there we go. So we got it correct now. So after we've done that, in that brackets, what we want to do is we want to round that score to. We don't want it to be too big. So what is wrong with this right now? So what we're going to do is we're going to times that by 100, colon dot to F. So that means to do two decimal places. And then we're going to put percentage, but because after all it's a score, slash n, because I'm going to put a new line between everything. Okay, model. Okay, so we are going to get everything wrong here. There we go. So np.randomSeed. So trying model with 10 estimators. So here is our results for each number of estimators. So if you want to clarify which one's the best, well, I'd say the 10 estimators is working very well for me. Yours might be different amount of estimators, but 10 estimators is working really well for me. Okay, so now that we have sort of improved it, we know how many estimators now. So now that we've improved it to our taste, we are going to do number 6 now. So we're going to save a model and load it. So we're going to do this with the Python Pickle library. Now it sounds very weird, but it's actually a pretty good library if you want to save and load models. So before I do that, in here I'm going to create a new folder and I'm going to rename it to machine learning models. Okay, and then we can save it there. So import Pickle. So then we're going to go Pickle dot dump. So we want to dump the CLF or our model, and we want to dump it into this file. So we're going to open this file. So I'm going to open I forgot what it's called, machine learning models file. So machine learning models, and then we're going to put I'm going to call mine random forest model 1, okay, dot pkl or pickle format. And then we want to put in what sort of format, so what sort of form we want to put it in. So we're going to put WB, so that will let us sort of put in our model into it or something like that. So it will let us actually edit the model, put it in there. So now, once we have done that, if we go into machine learning models, we've got our random forest model1.pkl. So that is obviously going to give an error because you can't really view those sort of models, okay? So yeah, so once we have done that, we're going to view our model as well. So I'm going to say loaded model is equal to pickle.load. So again, I'm going to open. So it is in my machine learning models folder. We're going to open random forest model 1, and this time we're going to open it as RB. So now we're just going to read it, we're not really going to edit it. Okay, so let's just okay, so let's view our loaded model, or actually we'll view the score. So loaded model dot score x test and y test. So it should now file not found error random. Okay, so it has not found that because we haven't put the PKL extension. There we go. So that score is now basically this score up here. So it's going to obviously give us that score. So yes, we have actually been through a lot now. So it has been 36 minutes actually. So it's been pretty long. We have learned a typical Scikit-Learn workflow. So now, if you haven't understood this, that is completely fine. At least you know what we had just done, all the steps, and now you're quite familiar with it. So we're going to be going through each of these steps in detail throughout the next few videos. So in the next video, we're going to learn how to split our data into training sets and test sets. I'm going to explain a bit more using Scikit-Learn's train test split library. So if you like this video, please like and subscribe. If you have any doubts, please comment them in the comment section below. I'll answer them. And if you have any comments, put them in there too. So yes, I guess that's the end of this video. Bye!